let's look at Rolle's theorem. Rolle's theorem is one of the mean value theorems, and it gives you some idea about a point in between two other points. Okay, so let's look at the statement of this theorem. If f of x is a function on a comma b closed interval ab such that f of x is continuous on the closed interval a comma b, f of x is differentiable in the open interval a comma b, and f of a is equal to f of b. Now the moment you see f of a is equal to f of b, what do you think of? If you visualize a graph, you have 2 points a and b, right? So that means the f of x or f of a, if it is this, then f of b would also be the same value. That means the curve can do anything it wants in between, right? It can go like this, it can go in any form, right? Say for example, it can go like this also, or it can go like this as well. So the point is, we know that f of a and f of b are equal. Okay, now that you have got that idea, let's proceed with the statement. Then there exists at least one value of x equal to c such that c is between a and b, for which f prime of c equal to 0. Now remember, f prime of c equal to 0 means the slope is 0. So what this means graphically is that you will find a point C such that the slope will be 0. Yes, this is C, and it says at least. That means there can be more than one as well. So here if you see, if in this graph, if this is A, this is B, then you have one here and one here. Here also the slope is 0 and here also the slope is okay. Or we can also say that the tangent at x equal to c is parallel to x-axis. So remember these three conditions. If f of x is continuous on a comma b. Now if this condition is not there, that means what? You can never guarantee, right? There might be a gap, it might jump, so it has to be continuous. It should be differentiable. That means you should be able to figure out a derivative. Okay, so let's see. Let's solve one or two problems to understand how it works. Let's say f of x is equal to x square minus 6x plus 8, and we are interested in the closed interval 2 to 4. Now remember, f of x is a polynomial, and we have already seen that polynomials are continuous for all x belonging to real numbers, which means that also for closed interval 2, 4. Okay, f prime of x, if we differentiate this, we get 2x minus 6, right? It is derivable in 2, 4. We can see that it is derivable in 2, 4. So f of 2 is equal to in x square minus 6x plus 8, substitute 2. Remember, this is A, this is B. So f of A is 2 square minus 6 times 2 plus 8. 4 minus 12 plus 8, which is 8 plus 4, 12, 0. Now we have to check the other end, f of B. F of B is f of 4, which is 4 square minus 6 times 4 plus 8. 4 4 16, 6 4 are 24 plus 8. Okay, 16 plus 8 is 24, minus 24 is 0. So which means f of A equal to f of B is equal to 0. So all the three conditions satisfied, that it is continuous, it is differentiable, and f of A and f of B is equal to 0. So let's look at f prime of x is equal to 0. So 2x minus 6 equal to 0, 2x equal to 6, x equal to 3. So therefore the slope is at x equal to 3, which belongs to the closed interval 2, 4 is 0. So that satisfies Rolle's theorem. Let's look at the next problem. Okay, f of x is equal to x times x plus 3 e to the power of minus x by 2 in the closed interval minus 3 comma 0. Now let's look at this. So first thing we have to figure out is the first condition, that is whether it is continuous or not in the closed interval minus 3 comma 0. Now think of it like this: if you substitute x with minus 3, so minus minus plus, so plus 3 by 2 it becomes, right? Similarly, if you put 0, this minus disappears, the whole thing becomes 0. So that means this entire function remains positive, or the expression associated with this function is positive, right? So which means is continuous. Otherwise what will happen is, if it was not a negative closed interval, then e to the power of minus x by 2 would have gone down, right? Because this would have remained negative, it would have gone to the denominator, and it would not have been continuous. Okay, so is continuous in the interval minus 3 comma 0. Since e to the power of minus x by 2 becomes e to the power of x by 2 in this interval, or if it is 0, then it becomes 1. Okay, now let's look at differentiability. Let's differentiate f of x. Now here you have three parts to it, so we need to apply the product rule. So let's differentiate x, rest remains as it is, plus, now x remains as it is, differentiate x plus 3, e to the power of minus x by 2 remains as it is. Then x times x plus 3 remains as it is, and we have to differentiate e to the power of minus x by 2. So e to the power of minus x by 2 times minus 1 by 2. Okay, now here if you notice, e to the power of minus x by 2 is common, so let's take it out. Now x plus 3 plus x, now this minus we can bring it to the front, so minus x times x plus 3 by 2. Yes. Okay, let's simplify. Minus x by 2, 2x plus 3 plus 2x minus x square minus 3x by 2 e to the power of minus x by 2, 2x plus 2x 4x, 4x minus 3x is x, so minus x square plus x, then this I didn't multiply it with 2, so 6 it will be, so plus 6 by 2. Okay, so we know it is differentiable in the for all x belonging to minus 3 comma 0. Now the third condition is f of a is equal to f of b. Remember, so f of minus 3 is equal to what? Remember, we are talking of x times x plus 3. So x here is minus 3 times minus 3 plus 3 e to the power of minus 3 by 2. Minus into minus plus, so plus 3 by 2. This becomes 0, so this entire thing is 0. Similarly, f of 0. So here what happens? This becomes 0 into 0 plus 3 e to the power of 0 by 2. Now because this is 0, this entire thing is 0. So f of minus 3 is equal to f of 0 is equal to 0. So now let's figure out f prime of x, the point that we are interested in where the slope is 0. So f of prime of x is equal to 0 means what? We differentiated it. So we got this e to the power of minus x by 2 minus x square plus x plus 6 by 2 is equal to 0. The denominator disappears when we take it to the other side. So this also disappears when we take it to the other side. Now minus x square plus x plus 6 equal to 0. Or we can write it as x square minus x minus 6 equal to 0. Which is x is equal to 0. 3 times 2, yes. So 3, 2. This is minus, so one of them has to be, the bigger one has to be minus. And this will be plus. Therefore, x equal to 3 or x equal to minus 2. So which means at these 2 points, the slope is 0 or tangent is parallel to x-axis, right? Now because these 3 conditions are satisfied as per Rolle's theorem, that is why we can say confidently that at these 2 points the slope is 0. So that is Rolle's theorem. Bye for now.